waste material in highway construction. We have already covered use of fly ash in embankment construction as well as in the structural concrete and PQC. So today we will discuss on use of waste plastic. So for this lecture, we are inviting Dr. P.K. Jain sir. P.K. Jain sir is retired from the head of the Department of Flexible Payment Division of Central Road Research Institute. During this 3 hour session, he will give you the details regarding statutory guidelines, advantage of waste plastic material characteristics, mixed design guidelines and construction methods for use in payment courses, quality assurance, quality control, and acceptance criteria. And in addition to that, he will also discuss some case study with all the participants. So I will request once again to the participant, please ask your questions, please clear your doubts. If you have any, our faculty will be happy to see your active participation from your side. And and if you ask your questions, so we from the side of the IHE, we felt that the training is more successful. Otherwise, one-way training is, I think, is not more useful than the two-way communication from faculty side as well as from the participation side. So I will request to all the participants, please ask more questions so that this session can be a interactive session. During this 3 hour session, there will also be a 15 minutes time break at about 11:15 to 11:30. Participant can also ask the question during the presentation as well as at the end of the presentation. But during the presentation, if the participant have any question, first of all, they have to take the permission from our faculty. However, at the end of the presentation, there will also be a question session. In that, all the participants can ask the questions, and I personally request to the participant, please ask more questions so that all participants can take the advantage of your questions answer session. Okay, so now I request Dr. If Dr. P.K. Jain sir has joined. So Dr. Now the Dr. P.K. Jain sir will share his presentation and experience with all the participants. Till the Jain sir will join, please wait for some time. Thanking you.
Good morning. Am I audible? सुन पा रहे हैं मुझको?
Sir.
Yes, sir.
हाँ, okay.
Yes, sir. Audible. Good morning, sir.
Okay. So, today morning's topic is use of rubber and plastic waste in road construction. So, क्या? तो क्या करो, बदलोगे? टी पे बदल लेना ना. Tires also and contribute to total 6% of the global tire waste, India alone. Plastic waste constitutes significant portion of the MSW, which is about 8 to 9% and dumped in out is creating environmental as well as the health as well as the fire hazard. Every Indian generate about 5 to 10 kg of the plastic waste in a year, depending upon status of the urbanization. Some cities generate more waste and some little bit less. The total plastic waste generated is about more than 9.5 million ton, out of which more than 5 million ton is recycled and the rest is dumped. Disposal of non-biodegradable waste is a issue of serious concern because it is not degrade and we have to look for alternative uses of this non-biodegradable waste like plastic waste. The use of 1 ton of the waste tire rubber, if used in road construction, can reduce about 1.1 to 2 ton of the carbon dioxide in the environment. So therefore, these are the two specific waste. One is the plastic waste and another one is the rubber tires, truck tires, vehicle tires. Reduction of the 8 to 15 ton carbon dioxide per lane kilometer is possible if we use used rubber from the used tires in road construction. Similarly, the use of plastic waste and used tires in road construction is the need of the day to have a cleaner India, more clean India. Prime Minister also announced and suggested the use of rubber and plastic in road construction to alleviate its disposal problem. Waste is wealth, and we have to look for alternatives, methods, and technologies where we can make utilization of the waste in road construction and other construction activities, developmental activities. And roads are one of the best consumer of the waste. Let us use non-biodegradable waste like plastic waste and as well as the truck tire, rubber from truck tires in road construction. In this slide, you can see the scenario of disposal of the plastic. On the top of the left hand side, you can see that entire plastic is dumped in the drainage, in the drain, and it has totally clogged the drain. And on the right hand side, you can see how the plastic is outside and making wastage of usable good. And also, it's all of us know conventional are less durable, are not durable, and develop cracking, stripping, and cohesion. Premature distress on the road due to stress of climate, traffic, overloading. Bitumen is highly temperature susceptible, prone to oxidative hardening and as well as early cracking. Cracking represents permanent distress in bituminous roads and need to be addressed so that have roads made by VG grade bitumen often develop distress like fatigue cracking, rutting, as well as the potholes in rainy season. Plastic contains many useful polymeric materials which modifies the bitumen for better engineering properties. There are various merits of modification by polymeric materials. Plastic and rubber waste modify bituminous mixes and have advantage over conventional bituminous mixes. Polymer and rubber present in plastic and tire rubber improve bituminous binders and engineering properties of the bituminous mixes, resist moisture damage, resist oxidative hardening, resist fatigue cracking, resist deformation, bleeding, and reduce the tendency of pothole formation, and ultimately add to the improvement in the longevity of the bituminous surfacing. The if we consider the plastic waste, the optimum dose is 6 to 8% by weight of bitumen. At the same time, if we consider crumb rubber from tires, the optimum dose is 8 to about 10%. Uh, Therefore, roads are better candidate for use of this non-biodegradable waste, particularly in our country. Sources of the plastic waste in India. There are various sources of the plastic waste in India, like grocery bags, used containers, water bottles, curd pouches, milk pouches, yogurt, cups, toys, etc. And the plastic or polymer used in making these goods is not biodegradable, and therefore it cannot degrade in the soil. It is dumped outside cities, villages, causing breeding of the mosquitoes, clogging of the drainage system, and many a times presence of this plastic in forest areas lead to fire. The leachate from dumping affect fertility of soil, and many a times you push throw plastic along with the eatables, and that is eaten by the animals, creating the health problems. And many a times these cows and buffaloes dies because of uh, eating the plastic. There are several advantages of plastic waste modified mixes for road construction. Plastic coats the aggregate surface, altering its surface properties such as reduction in water absorption as well as stripping of the bitumen in under the influence of water. It improve fatigue life of bituminous mixes. Stiff bitumen and mixes prevent bleeding, rotting, and deformation at high temperature. It improves the stability, enhance the stability of the mix, as well as the stiffness modulus. It also reduce up to some extent low temperature brittleness of bitumen and bituminous mixes. It enhances the fatigue life of bituminous surfacing, where high strains are imposed by the higher traffic and overloading. It improves resistance to raveling and pothole development on the roads during rainy season. And other advantage is if we mix plastic, it permits a thicker film of the bitumen over the aggregate, contributing to the better durability, improved durability of surfacing, reduce maintenance interventions, and solve problem of plastic disposal at the same time. So requirement of the maintenance may be reduced if we are using plastic waste in bituminous road construction. Now we have to understand when we are going to utilize any waste in road construction activities. So we must understand about the material also. So depending upon physical properties, plastics are waste plastic also classified into two parts, two types. One is thermoplastic plastic and other one is the thermosetting plastic. So what is the difference between thermoplastic plastic and thermosetting plastic? Thermoplastic plastic melts upon heating and becomes solid upon cooling, and this can be remolded and ideally compatible with the bitumen. But the thermosetting plastic, once heated, it cannot be remolded back. So we cannot transform one form of the thermosetting plastic into other form, and this is not compatible with the bitumen. Thermoplastic plastic can be formed to degrade safe under heat and pressure and become solid on cooling. Thermosetting plastic material which once shaped cannot be remolded or converted to the original shall not be used with road construction. So, in this table, you can see what are thermoplastic plastic and what are thermosetting plastic. Polyethylene, polypropylene, polyvinyl chloride, polystyrene, low density polyethylene, and high density polyethylene are thermoplastic plastic. Similarly, the plastic like bakelite, epoxy, melamine, polyester, urea formaldehyde, and resins, alkyd resins are placed under the category of thermosetting plastic. What are the source of different types of thermoplastic plastic which can be used in road construction? For example, low density polyethylene. The sources are carry bags, sacks, milk pouches, detergent bottles, etc. High density polyethylene sources are carry bags, bottle caps, many household articles. Polyethylene terephthalate sources are drinking water bottles. Polypropylene, the source is microwave trays, closures, wrappers. Polystyrene, food trays, egg boxes, yogurt cups are the source. Polyolefin, the major source are shoe soles and chappals, etc. Polyvinyl chloride, the sources are pen, folders, electrical goods, pipes, furniture, folders, toys, pens, medical disposals, and water containers. So this was a basic idea about the plastics, various types of the plastics, and the plastic which can be used in road construction. All plastic cannot be used in road construction, so we must be very clear about it. Now, the code of practice. Whenever we use a material in road construction, there is a need of code of practice or standard or specification. So, the code of practice for use of plastic waste in road construction are guidelines for use of plastic in hot bituminous mixes by dry process in varying course are given in IRC SP 98 2013. The use of rubber and plastic modified binders in road construction are also given in IRC SP 53 to 2010 and IS 15462 deals with use of rubber and use of polymers in road construction. Indirectly, this code also help us in using the plastic waste in road construction. There are various benefits, social benefits also. Therefore, we are talking about plastic waste in road construction. Rural India generate millions of ton of plastic in a year, and urban India generates about 4 million ton plastic waste in a year. If we start using plastic waste in road construction, then will be the social benefits? We will not be dumping on the roads. Drains will not be clogging, and housewives may also be benefited by getting some price of the plastic waste if it is used in road construction. Then, if it is used in road construction, it may be a priced item. Estimated income is about 250 to 500 per day for the laborers. Those are engaged in their collection, cleaning, and shredding. Being a price product will not be thrown into the streets. Rag pickers will be benefited by selling these plastic waste for road construction activities to the shredders. Reduced chances of infection, that is a environmental benefit, that is a health benefit, and fire due to MSW free from this non-biodegradable plastic waste is a another safety benefit. Plastic waste constitute, as we know, we discussed, 8 to 10% of MSW, and it harms the environment. Use in problem of the plastic. The use, no breeding of the flies, mosquitoes, and no contamination to soil, no fire in the forest, and no draining, clogging of the drainage system. Those are the environmental advantages. Now I am coming to the collection procedure. Plastic can be collected in separate dustbin in the houses or streets. Sides, we can put separate dustbins for disposal of the plastic, for throwing the plastic, used plastic bags, and those can be collected through garbage trucks separately, may be collected by kabadis as well as rag pickers, uh, may be collected through programs in schools or NGOs. Municipal corporation may open buying centers and may be sold to the centers by rag pickers or kabadis. Rag pickers may collect from MSW sites also and then sell them to the municipal centers. Or there may be a buyback scheme by the shopkeeper uh, and milk sellers. So in this slide, I am showing you some of the picture we can have, like slide number 1, separate dustbin for plastic waste. And then these can be carried, collected by our laborers. They can be cleaned, and these can be collected by rag pickers like bottom slide. And on the right hand side, a system, these can be packed in bags of the net. If plastic is used in road construction, there is a requirement, it should be clean, free from, otherwise it may be harmful to durability of bituminous roads. Therefore, plastic waste should be stored, cleaned, and washed before packing. And washing may be done in tanks or baskets, and it shall be made free PVC here. Therefore, it involves employment, employment also for picking, for cleaning also, and packing also. The next step, once the plastic is dried and cleaned, then it has to be converted into a usable form. Its size has to be reduced by a process known as shredding. Clean and usable plastic shall be shredded to specified size as specified in the standard IRC standard using a shredding machine. Before shredding, all plastic which is black in color, supposed to be having PVC, shall be removed because that is harmful to the health, to the construction workers during road construction. Shredded plastic shall be packed in bags of 25 kg. The size of plastic for road construction shall be 1.18 millimeter to 4.75 millimeter. In the picture, you can see a shredding machine on the left hand side, another shredding machine in the middle of the slide. In the picture, you can see, and on the right hand side, after shredding, the plastic is packed in the bags. The 25 kg plastic can be packed in a bag. So now specification. Whenever we use a waste or a product, a material in road construction, we have to have the specification. Therefore, specification for plastic waste has also been drafted and developed by IRC and other agencies like uh, Rural Road specification. Useful plastic for road construction comprise polyethylene, polypropylene, polyurethane, polyethylene, terephthalate, polyolefin, etc. Plastic shall be made clean before use in road construction, free from dust, food, impurities, and organic matter, and the ash content shall not exceed 1%. It shall be shredded after cleaning to the size of 1.18 mm to 4.75 mm. Things are very clear. I am telling you, the melt flow value tested as per ASTM is standard, but this is optional, not necessary. And plastic, whichever is used in road construction, shall be thermally stable up to 200 degrees centigrade, and thermal stability of the plastic can be tested by a method which is known as thermogravimetric analysis method. For particle shape and size, the recommended test is sieve analysis. Precautions in construction. What kind of precautions are necessary in construction? We have different opinion about the doses. Some people say, but the research, detailed research and deep research has concluded that the quantity of plastic waste in road construction should not exceed 6% by weight of bitumen. The hot mix plant to be used in modification of the plastic by is to be fight. I will tell you later on. Plastic shall not be exposed to the. It will be modified in such a way that there should not be any contact between the flame and plastic or plastic coated aggregate. PVC containing used because when it is heated to a temperature exceeding 150 degrees centigrade, it emit toxic gases which may be harmful to the workers. Batch mix plant having additive addition system is more suitable for construction of waste plastic roads. In case of drum mix plant, the sum of the drum mix plant shall be modified, and it should have a central entry system, addition system, which I am going to explain you later on. In case of the batch type plant, it can be directly added to the pug mill, directly with the help of labor or with the help of a special uh, conveyor and bin. Plastic shall be cleaned before shredding. Temperature of the mixing and rolling. One thing you have to remember, that temperature of the mixing and rolling shall be 10 degrees centigrade higher than conventional mix. The another precaution is the quantity of bitumen shall not be reduced. In number of specification can use plastic for modification like open graded premix carpet as per Morse clause number 510, bituminous macadam as per Morse clause number 504, mixed seal surfacing as per clause number 508, dense bituminous concrete Morse clause number 507, DBM Morse clause number 505, and stone matrix asphalt Morse clause number 515. Now I will give you some tips about supervision of the construction and quality control. First of all, one of the important aspect is storage of the plastic because it is a flammable material. It can catch fire and which may become a serious problem. Storage and handling of plastic, collection and procurement may be done prior to start of construction work after finalization of the specification. Material shall be packed in bags of appropriate size. It will not be stored in open, preferably 25 kg, and it should be stored in shade, dry and cool place. 1 lane kilometer of the road requires 370 kg of the plastic waste for open graded premix Praga. 1 lane kilometer means 3,750 meters square meter. 370 kg of the plastic waste for open graded premix carpet. 720 kg plastic waste for closely graded premix carpet, that is also called mixed seal surfacing. 750 kg plastic waste for 40 BC. Load of A load of plastic waste may comprise 1 ton, which should be tested for field level test, and the recommended field level tests are sieve analysis test and ash content test. Plastic before shredding may be packed like this, as shown in the picture, in net, and this is storage and handling to be packed after shredding. It shall be packed into these bags. Specification: the plastic waste shall be consistently polypropylene, and plastic waste shall be shredded to the size of 1.75 mm. Now I am coming to two types of plants can be utilized for construction of the preparation of the plastic modified mix: modified drum mix plant or batch type hot mix plant. This is a modification of the plant, a mini hot mix plant, where there is a provision is made for adding the plastic over the aggregate in a drum of the drum mix plant. So the drum, we have two options. The drum of the drum mix plant has to be modified into three parts. One is the fire chamber, where the aggregate is heated. The second one is the chamber for shredded plastic waste, and the third one for adding the bitumen. Once the aggregate is heated on the left hand side, in the fire part, is aggregate is pushed to the middle part of the drum, where a opening is provided for adding the plastic over the heated aggregate. Here it is mixed with heated aggregate. The plastic melts and coat the aggregate, and then bitumen is added over the coated aggregate in the third part of the drum. This is a typical batch mix plant with a additive device. Can be a good option for making the plastic modified mix. These are the pictures of road construction activities with plastic bed. The paving system is same, whichever is used for other type of bituminous mixes. There is no change. All pavers, every type of the paver can be used, and similarly, you can see some of the roads, rural roads. Uh, uh, Pictures are shown on the right hand side. Now, what is important from construction point of view? That is the broad range of the temperature for construction. So, the binder at mixing temperature in the range of 165 for VG30, 160 for VG20, 175 for VG30, and 185 for VG40. Aggregate temperature 160 to 180, and we have to maintain a difference of 14 degrees centigrade between the temperature of the binder and the aggregate. Mix at mixing plant 140 to 160 degrees centigrade, mix at laying site 130 to 150 degrees centigrade, rolling at laying site 115 to 135 degrees centigrade. So there is a requirement of little bit about 15 degree higher temperature for rolling of the
Hello,
plastic
sir.
modified mix. Yes,
हेलो सर
yes,
ये सर एग्रीगेट और बिटवीन के टेम्परेचर डिफरेंस 14 डिग्री होना चाहिए
जी
तो हायर किसका
14
होना
डिग्री
चाहिए
का डिफरेंस होना चाहिए एग्रीगेट और बिटुमेन के टेम्परेचर में।
क्या हायर कौन होगा सर हायर और
हायर
लेसर इसमें
बिटुमेन
कौन
होगा,
होगा
बिटुमेन हायर होगा, एग्रीगेट नहीं। अगर एग्रीगेट हायर रखेंगे तो जल जाएगा बिटुमेन।
थैंक यू सर
So again, these are two pictures where we open graded premix carpet is under construction on a rural road using the plastic modified mix. This is another picture of highway where we are paving roads, bituminous roads with plastic modified mix. So then you can see the correct temperature. We should complete all compaction activities before the temperature drops below 90 degrees centigrade. Now I will take up the individual specifications like open graded premix carpet, which is a common road construction specification, particularly low traffic roads. So, preparation, laying, and compaction of 20 mm thick plastic waste modified premix carpet on a previously prepared base shall be done as per clause number 510 of Morse specification. I again request keep the dose of plastic 6% by weight of bitumen, and in construction of open graded premix carpet 310 to 310 kg 30 kg plastic shall be used for 1 lane kilometer road construction. So it is a ready reckoner for you. Modified hot mix plant shall be used. Device for addition of the plastic shall be attached with hot mix plant, preventing exposure of the plastic to the flame. Plastic shall be free from PVC and size shall be maintained. Black colored plastic shall be eliminated. Plastic waste shall be added on over the heated aggregate before addition of the bitumen. Temperature shall be 10 degree higher than the normal construction temperature and no reduction in the bitumen content. Some people claim reduction of the bitumen content, no reduction in the bitumen content. For 10 square meter area, the aggregate of nominal size 13.2, passing 22.4 and retained on 11.2 should be 0.18 cubic meter. Coarse aggregate of nominal size 11.2, passing 13.2 and retained on 5.6, 0.09 cubic meter. Bitumen VG10 to VG30. No VG40 bitumen grade bitumen is recommended for plastic waste 14.6 kg and plastic waste in 10 square meter area 0.88 kg. So these are the quantities. Preparation and laying. Requisite quantity of the plastic waste, that is 0.88 kg per 10 square meter area of required quality. Quality mean it should be passing 4.75 mm sieve. Waste plastic powder should be passing 4.75 mm sieve and it should be retained over 1.18 mm sieve. Shall be added to the mixed aggregate, heated to about 150 degrees centigrade before addition of the bitumen 14 degree higher. Base plastic aggregate shall be mixed thoroughly for 30 to 60 seconds. After the aggregate is mixed for 30 to 60 seconds with plastic waste, the required quantity of hot bitumen shall be added subsequently and mixed thoroughly again for about 2 minutes. Modified mix will be taken to the laying site in tippers covered with tarpaulin so that there is no temperature drop and is spreaded by paver to the required thickness and grade, followed by compaction as per procedure given in IRC 14. Rolling shall be done edge to center in a straight reach and left to right in case of the super elevation. Rolling shall be completed before temperature drop to 100 degrees centigrade. Cracks, if any, during rolling shall be corrected using a pneumatic tire rolling at the end. Commence initial rolling called breakdown rolling using a static three-wheel roller. Rolling to be from edge to center or lower edge to upper edge. Intermediate rolling may be done by vibratory roller. Final rolling by a smooth wheel roller. Overlap 1/3 of the previous pass of the roller. Transverse joint for single lane road. Cut vertical faces of the edges laid earlier and fill full depth. Bitumen. The procedure for mixing conventional construction of BM, DBC, MSS or SMA. In case of the bituminous macadam, plastic shall modified with plastic waste shall be constructed as per Morse clause number 504 in a thickness of 50 to 75 mm. Modified BM shall be used for upgradation work for strengthening if traffic is more than 1 MSA. For cold climate areas, 0.5% extra bitumen will be used. Prior proportioning of the aggregate shall be done after sieve analysis of the aggregate for compliance of the grading. Plastic waste shall be 6% by weight bitumen or 0.22% by weight of bituminous mixture. Mix can be prepared in a modified hot mix plant. For construction of 100 square meter area, grading given in Morse clause 504 shall be applicable. 25 kg of the plastic waste shall be added over heated aggregate. This 20 square meter area. 400 square meter area for a compacted thickness of 50 mmBm. Mix shall be prepared in a modified drum mix plant or a batch mix plant. This is the grading of bituminous macadam. Bitumen content by weight of total mixture shall be about 3.4%. And the grade of the bitumen may be VG10, VG20 or VG30. Now the next specification, mixed seal surfacing or closely graded premix carpet. MSS or closely graded premix carpet modified with plastic waste shall be given in Morse clause number 508. Prior proportioning of the aggregate shall be done after sieve analysis of the aggregate at site for compliance of the grading. For high rainfall areas, type A grading shall be used and type B grading shall be used for low rainfall areas. For construction of 100 square meter area, 2.7 cubic meter of the aggregate meeting the standard gradation shall be used and 330 kg of the bitumen and 19.8 kg of the plastic waste shall be used for 100 square meter area. So these are the gradings for hot mixed plastic waste modified mix A and type B, both are given. For high rainfall area, type A is recommended. For low rainfall area, type B is recommended. 19.2 kg of the plastic waste meeting the specification of the size free from PVC shall be added over the heated aggregate before adding the bitumen. Mix shall be prepared in a modified drum mix plant or a batch mix plant and transported to site in covered tippers spreaded by paver and rolling as per normal procedure. Now the bituminous concrete we generally use on national highways, state highways, and sometimes on MDR also. Plastic waste modified bituminous concrete is a continuously graded design mix prepared in hot mix plant, may be used on national highway with higher traffic. Mix shall be prepared in modified hot mix plant and transported in covered tippers. 30 to 50 mm thickness of plastic waste modified BC mix is recommended. A viscosity grade bitumen, preferably VG10 or VG30, VG10 for cold climate areas and VG30 for hot climate areas shall be used for plastic waste modified bitumen. VG40 is not recommended. Dose of plastic waste shall be decided by mixed design, which I will take up later on. This is the grading for semi-dense bituminous concrete, and this is the grading for semi-dense bituminous concrete, and requirement of the BC and DBM mix design criteria. Minimum stability 12 kilonewton, minimum flow 2, maximum flow 4, Marshall quotient 2.5 to 5, compaction 75 blows, ITS minimum 0.9, VMA 16%, VFB 65 to 75, and quantity of plastic waste 6% by weight of optimum bitumen content or as designed. Now I am coming to the requirement of the quality control. Aggregate bitumen filler shall be tested as per requirement of the subsection 504 for BM, for BC 508 for MSS, and 510 for open graded premix carpet. Plastic waste shall not be black, meet requirement of IRC specification. It may contain LDP, HDP, etc. Sieve analysis test and S content at site besides binder content and stripping test. Size of the plastic shall be again 4.75 to 1.18 mm and S content shall not exceed 1%. Clause number 900, that is the test and test frequencies applicable to conventional construction are also applicable to construction of various specification of plastic waste modified mixes. Field level test for plastic waste, some observations as well as tests are recommended. Number one, color of the plastic waste, not black. Ash content in plastic waste, less than 1%. Quality of the aggregate as per specification of MORTH. Quality of binder as per specification of MORTH. Sieving of the plastic waste, optimum dose of the plastic waste by mixed design. There is no need of the mixed design for PM, open graded premix carpet or mixed seal surfacing, but the mixed design requirements are there for DBM, SMA, and BC. Other tests, binder content in mix, thickness of the loose mix, thickness of the layer, temperature of the binder, temperature of the aggregate, temperature of the mix, density of the compacted layer, stability, void analysis. Now, how do you carry out, you have to carry out the sieve analysis test of the plastic waste. Take 100 gram of the plastic waste and dry it in a plate at 105 degrees centigrade for 4 hours in an oven. Take 3 sieves, 4.75 mm, 1.18 mm, and 75 micron, and do the sieve analysis. Plastic must pass 100% through 4.75 mm and must be retained about 98% on 1.18 mm. Material passing 75 micron shall not exceed 2% and tested for ash content by heating at 600 degrees centigrade. So this is the procedure. Another important test, it is expected that there is no stripping in the aggregate if it is coated with plastic waste. So stripping test has to be carried out to carry out the stripping test in case of plastic waste modified mix. So take 600 gram of the aggregate passing 20 mm and retained on 12.5 mm sieve. Wash and dry the aggregate in oven at 120 degrees centigrade for 4 hours. Transfer aggregate in a pan. Add 3 gram of the plastic waste and mix with heated aggregate at 150 degrees centigrade for 60 seconds. Add 30 gram of the bitumen over plastic coated aggregate and mix for 60 seconds. Cool mix for 1 hour. Place equally in 3 beakers of 500 ml each. Add distilled water. Condition at 40 degrees centigrade for 24 hours in water bath and observe the coated area next day and report percent coating based on visual observation. So this is the procedure. And now you can see the lady is doing test on the left hand side, and on the right hand side you can see the aggregate after test. Now the binder content test in plastic mix, it is slightly different than normal test. So how to do the binder content test? Weigh 500 gram plastic containing mix, a representative sample after quartering the mix in the tray. We can take 2 kg mix in a tray, and after quartering we can take 500 gram. Place the mix in a extraction bowl at 120 to 130 degrees centigrade. Pour trichloroethylene in the mix. Submerge in the solvent. Mix with a spatula and allow for 30 minutes. After closing the lid, centrifuge and collect the solvent plus filler in a 2-liter beaker. Weigh aggregate mix and reflex in a round bottom flask with a solvent that is called decathlon for 30 minutes. Dry aggregate free from plastic because plastic will dissolve in decathlon and cool and take the weight. Difference between weight of mix and aggregate plus filler in bitumen is the bitumen content in the plastic waste modified mix. You can see here, first of all, we have to do the extraction test. Then on the right hand side, you can see the aggregate, washed aggregate from trichloroethylene, which you can see some black color indicating that it is not completely washed. Test during construction, grading, stability void analysis, binder content, temperature of aggregate, temperature of mix, thickness of the compacted layer, and density. Regarding the density, one test for 700 square meter area has to be carried out. Now, at the end of this part of the lecture, what are do's and don'ts? Do's: remove black plastic before use, shall be clean and stored away from the fire. Modification in hot mix plant is required for smooth addition of the plastic in hot mix plant without any decomposition. Don'ts: plastic waste shall not be in contact with flame in the drum of the drum mix plant. Mixing and rolling shall be done at 10 degrees centigrade higher temperature. Do not add excess quantity of the plastic waste as it may make a stiffer mix, causing difficulty in rolling, and mix may crack early. So,
আইসক্রিম
this,
একটা খান
yes,
এটা খাইতেইব কাগজটা দিলে খাইবে
with this, this part of the lecture is completed. Now I will show you a film on use of plastic waste. टाइम हो गया तो हो जाएगी फिल्म 40 से 20 मिनट की है। नहीं तो खोल रहे हो प्लास्टिक वेस्ट खोलो ना आ गया ये नहीं है नीरज कौन साइन कर रहे हो
so sure.
साउंड नहीं आ रहा है सर इसमें। हेलो।
सर आवाज नहीं आ रहा।
मेरे पास मेल कर दो सर। मैं बताता हूँ, मेल कर दो, व्हाट्सएप कर दो। आशीष आ गया क्या? Awesome.
सर आवाज नहीं आ रही सर, साउंड इंटरप्टेड सर।
साउंड ठीक किया जाए सर, साउंड एकदम नहीं है। हेलो
हेलो सर, साउंड नहीं नहीं आ रहा है सर।
वी आर म्यूचुअली डिस्कसिंग,
उनको साउंड नहीं जा रहा,
अपन लोग आपस में बात कर रहे हैं,
उनको साउंड नहीं जा रहा, साउंड
नहीं आ रहा है।
बहुत ये कुछ टेक्निकल प्रॉब्लम है। क्यों हर बार यार इस वीडियो पे साउंड जाता नहीं ना, वहाँ आवाज नहीं जा रही, पहले वीडियो दिख रही है बट वहाँ साउंड नहीं पहुंच रहा।
तो कैसे होगा?
तो मैं वो करूँगा, चलो मेल कर बोलो, हम मेल कर देंगे इनको,
वो मेल कर दो,
तो मेल कर दो, अभी वही करूँगा मैं,
देख ले,
वही बोल दो आप,
बोल देता हूँ।
कर देते हैं 15 मिनट।
Mute है, unmute है।
अनम्यूट
Hello, we will give you a copy of this film so you can see at your end with sound.
ओके ओके सर, ओके सर, थैंक यू।
ओके सर, थैंक यू।
अभी खत्म तो हो जाने दो। So now we have tea break for 15 minutes.
स्टार्ट सर।
Okay. So now I will take up second part of this lecture, that is design of plastic modified mixes and some case studies, examples. We have already discussed about use of plastic and its disposal. Problem with the use of plastic is its misuse. There is a misuse. It's dumping on roads, pits, drains, and plastic material which is dumped find their way to drainage system and clog these, besides posing other hazards like fire, soil fertility, environmental degradation, and uh, pollution. So we have already discussed uh, the merits of using the plastic, its specification, code of practice. So these are the different types of, of mixes where plastic can be used. So
Sir, audio
what
not
is
visible, sir.
plastic? ऑडियो नहीं आ रहा है. हेलो, आप सुन नहीं पा रहे हैं क्या? हेलो,
बराबर नहीं सुने आ रहा है सर.
एक मिनट, जस्ट मिनट. ओ हो रखा था. हेलो, सुन पा रहे हैं? हेलो, कोई बोल नहीं रहा.
आ रही है सर, आवाज आपकी आ रही है सर.
ओके ओके ओके. तो व्हाट इज ए प्लास्टिक modified mix? It is a mixture of coarse aggregate, fine aggregate, mineral filler, plastic waste, and bitumen. So to design a mix with plastic waste, what has to be done? The well-graded aggregate and the mineral filler resulting in maximum density when mixed with optimum quantity of plastic, waste plastic of appropriate specification, required specification, and bitumen results in a mix with good stability, high ITS, and high durability.
सर नहीं सुने आ रहा है.
Hello, sir. We can't hear you.
Hello? Hello?
सर हेलो सर नाउ यू
हाँ,
कैन
सुन रहे हैं?
हाँ सुन रहे
सुन रहे हैं?
हाँ सर
सुन पा रहे हैं? ओके.
हाँ सर
The plastic modified mix must be workable at application temperature. Why this aspect is very important? Because when we mix the waste plastic in a bituminous mix, the mix is likely to become more stiffer. And if mix is too stiffer, then it creates the workability problem. The mix must be able to resist the permanent deformation. The mix must be able to resist the cracking. Mix must be impermeable to ingress of the water to lower layers. It should be durable under prevailing traffic and environmental conditions. Contribute to pavement strength. With respect to noise, it should be less noisy, resistant to skidding in wet condition. Optimum dose of the plastic waste must be utilized. Use of local materials with respect to aggregate, etc., should be made, and it should be cost effective. The purpose of the mix design, if we are using plastic waste, mix design is necessary. If we are using plastic waste in DBM, BC, SDBC, SMA, the mix design is carried out to arrive at a job mix formula, producing the economical mix with with improvement in following properties like durability, stability, voids, flexibility, and workability. Basically, mix design consists of a procedure to select aggregates, proportioning and gradation, binder type and binder content, optimum dose of usable plastic waste to produce a bitumen aggregate mix that satisfy specific requirement of the road pavement. Now, how to do the mix design? The procedure is same as we do the mix design for normal bituminous weak mix. So briefly, I will review the mix design procedure. It involves various steps are selection of the aggregate, selection of the plastic waste, selection of the aggregate gradation, proportioning of the aggregate to meet the required gradation, selection of the bitumen. Selection of the bitumen is also important. If we are using plastic waste, the use of VG40 should be avoided. Preparation of the Marshall specimen, testing of the specimen for density, stability, and flow, density void analysis, and determination of the optimum bitumen content, and computation of the material for 100 square meter area apparatus. Apparatus are normal Marshall apparatus. It comprises mold assembly, cylindrical molds consisting of base plate and collar, compaction pedestal and hammer. The weight is 4.54 kg from a free fall of 45.7 centimeter. Breaking head inside radius of curvature of 5 centimeter, loading machine and flow meter. Design criteria. As per MORTH specification, the design criteria for BC and DBM is given here. Design criteria applicable to modified bitumen shall be applicable to plastic waste modified mix. The requirement of stability for hot climate shall be 12 kilonewton and requirement of stability for cold climate shall be 10 kilonewton. Marshall flow 2.5 to 4, 3.5 to 5. Marshall quotient stability divided by flow 2.5 to 5. Marshall quotient is very important nowadays. Majority of the vehicles are carrying excess weight and excessive tire pressure. So, due to excessive weight and excessive tire pressure, the deterioration of bituminous surface is faster. So, the Marshall quotient becomes very important and its value should be in between 2.5 to 5. Air voids 3 to 5. Voids filled with bitumen 65 to 75. Coating strength ratio 90% minimum. There are two gradings for BM, grading 1 and grading 2. Grading 1 for 40 mm nominal size aggregate and grading 2 for 19 mm. And layer thickness for grading M1 is 80 to 100 mm and grading 2 50 to 75. Similarly, for DBM, there are two grading 1 and grading 2. Size of the aggregate for grading 1 is 40 mm and grading 2 25 mm. Layer thickness for grading 1 is 80 to 100 mm and for grading 2 50 to 75 mm. Similarly, for BC also there are two gradings. Grading 1 50 to 65 mm thickness and grading 2 for 30 to 45 mm layer thickness. So before start of the mixed design, the first step is grading of the available aggregate as we do for normal mixed design. For example, we have 4 aggregates. Aggregate A 20 mm, aggregate B 10 mm, aggregate C stone dust and the filler. So in this slide, as an example, you can see the data of sieve analysis. So we have to do blending of proportioning of the aggregate in such manner that we get close to grading close to middle line of the standard grading. Many methods are available like trial and error method, mathematical method and graphical method for blending of the aggregates for proportioning purpose. So Based on sieve analysis, the proportioning of the mineral aggregate A, B, C and filler has been done, and it is found that if we blend 24% of the A, 30% of the B, 42% of the C and 4% of the filler, we get the combined grading which is close to the mean value of the specified grading as indicated by green line. Then we have to plot the grading in a chart, gradation chart, and we can see that the grading of the blended aggregate is well within the permissible limit. Then the next step is selection of the bitumen. A proper grade of the bitumen is required to be selected, and it should satisfy the specification and properties and limits given in IS 73 2013. In case of the plastic waste modified mix, the modified bitumen shall not be used. Now we have to prepare the specimen. We have to take the plastic meeting the requirement of the specification, gradation, quality, and we have to prepare the specimen for optimum bitumen content. First, we will prepare the specimen for optimum bitumen content, and the coarse aggregate, fine aggregate, and the filler material should be proportioned and mixed as per the dry mix design. Required quantity of the dry mix is then taken so as to produce compacted bituminous specimen of thickness 63.5 mm approximately. 11 gram, 100 gram of the aggregate and the filler is taken to get the standard specimen. The dry mix of the aggregate and the filler is heated to a temperature of 150 to 160 degrees centigrade. The compacted mold assembly and hammer are cleaned and kept preheated to a temperature of 100 to 240 degrees centigrade. The bitumen is heated to a temperature of 150 to 165. Samples are prepared, 3 each at each bitumen content with the first trial percentage of the plastic waste and the bitumen. The mixing temperature of the VG30 is about 165 degrees centigrade. Marshall molds for preparation specimen of 101.6 mm diameter and 63.5 mm height are taken, consist of base plate, forming mold and collar. Interchangeable base plate and collar are to be used on either end of the convection mold. The mix is placed in the mold and the compacted by hammer with about 75 blows in each side. The weight of the hammer is 4.54 kg and height of the fall is 457 millimeter. Compacting temperature may be around 135. The compacting specimen should have a thickness of 63.5 plus minus 1.3 mm. After curing the specimen for a day, samples are to be extracted. The minimum time gap between preparation of the sample and extraction shall be 6 hours. The compacted specimens are extracted using a sample extractor after curing time. Sample extractor is designed for fast extrusion of the samples from compaction molds. At least 3 specimens shall be prepared at each trial bitumen content, which may be varied at 0.5% increment. Similarly, at least 3 specimens shall be prepared For each trial plastic waste content, this is the composition of a Marshall specimen, which comprises coated aggregate, plastic waste coated aggregate, bitumen, voids, fine aggregate, and the mineral filler. So, after preparation of the specimen and taking out the specimen from the molds, following quantities are to be worked out by carrying out density void analysis. Bulk specific gravity of the compacted mixture, bulk specific gravity of the aggregate, theoretical maximum specific gravity of the aggregate, percent air voids in the final mix, percent air voids in mineral aggregate, and percent aggregate voids filled with bitumen. Bulk specific gravity of the compacted Marshall specimen shall be determined by weighing the Marshall sample in air as well as in water. If specimen has a where W and WW are weight of the specimen in air and water. Next, if samples are porous, we have porous samples in case of the BM, bituminous macadam. The specimen has open impermeable surface. The procedure given in ASTM D1188 shall be adopted and GMB shall be calculated by the formula W divided by W dash minus W dash W, W minus W divided by GP, where W dash is equal to weight of coated specimen in air, weight of coated specimen in water, WW, and then GP is the specific gravity of the paraffin coating at 25 degrees centigrade. Then we will calculate the bulk specific gravity of the combined aggregate by the formula GA is equal to PCA plus PFA plus PMF divided by PCA divided by GCA, PFA divided by GFA, and PMF divided by GMF. We have to determine the maximum theoretical specific gravity by the Rice method, or it may be calculated by following formula GT is equal to W divided by PCA divided by GCA, PFA divided by GFA, PMF divided by GMF plus PB, percentage of bitumen divided by GB, specific gravity of the bitumen. Then we have to calculate the voids in the final mix. 100 multiplied by GT minus GMB divided by GT. GT is the theoretical specific gravity and GMB is the experimental bulk density of the specimen. Then we have to calculate the voids in mineral aggregate. Then aggregate voids filled with bitumen. VFB is equal to 100 multiplied by VMA minus VV divided by VMA. After that, all the specimens are to be tested in water controlled at 60 degree plus minus 1 degree for 30 to 40 minutes. Marshal take out the specimen from water bath and place in a breaking head. Place the breaking head in the Marshal testing machine and the load is applied on the breaking head by loading machine at the rate of 5 centimeter per minute. Stability value is the load taken by the specimen at failure and flow value is the deformation of the specimen at failure. Record stability either by proving ring or load cell. Record the flow either by dial gauge or displacement cell attached with the breaking head. stability value are required to be corrected because the standard stability value is meant only for a specimen of 63.5 centimeter height. These are the correction factors. So this all these steps are similar to the conventional Marshall method of the mixed design. Then optimum bitumen content shall be determined by plotting the graph versus unit weight versus bitumen content, Marshall stability versus bitumen content, voids in mix versus bitumen content, aggregate voids filled with bitumen versus bitumen content, and flow value versus bitumen content. These are the plots. Now we will see the difference. After getting the optimum bitumen content, what we will do, we will determine the optimum plastic content in the mix. So at optimum bitumen, say optimum bitumen content is 5.5%. We will prepare samples at optimum bitumen content varying the plastic content. So we can prepare the sample at 5% plastic content, 6% plastic content, 7% plastic content, and 8% plastic content. And all the properties like stability, flow, voids, voids filled with bitumen, voids in mineral aggregate shall be determined. So this slide shows you comparison of two mixes, one without plastic waste and other one with plastic waste. So we can see that with plastic waste, the stability values are high and flow is less. So the Marshall quotient of mix with plastic waste is always towards higher side. But remember, it should not exceed 500 kg per mm. And if you add more plastic, it will definitely exceed 500 mm, and mix will become stiffer, and you will face difficulty in paving and compaction, and surface may crack early if there is a lower temperature in the winter. Another important factor for mixed design is filler to bitumen ratio. The filler to bitumen ratio shall be in the range of 0.6 to 1.2 by weight. For example, if filler is 40 gram and bitumen is 51 gram, then filler to bitumen ratio is 0.78, which is acceptable. If filler to bitumen ratio is less than 0.6, it indicates stability is insufficient. If filler to bitumen ratio is more than 1.2, it indicates durability is affected. The recommended filler is hydrated lime because it has certain advantages, as hydrated lime reduces stripping, it has mineral filler, stiff the bitumen binder, improve resistance to fracture growth, favorably alter the oxidation kinetics, and interacts with the products of oxidation, reducing the harmful effects. It alters the plastic properties of clay fines in the fine aggregate, improving the moisture susceptibility as well as durability. So then bitumen and plastic waste ratio. So it can be determined by ITS test, determine optimum bitumen content by Marshall method, prepare samples at 5, 6, 7, and 8% plastic by weight of optimum bitumen content, and prepare set of 6 specimens at each plastic content and test for ITS and ITS ratio. The highest ITS ratio, how do you find out the optimum plastic content? The highest ITS ratio you get will be the deciding factor for optimum plastic content in a bituminous mix. So this way the mix design is completed. Now next is the performance studies on the plastic modified mixes. There are three important tests like indirect tensile strength test, fatigue test, and rating test. Indirect tensile strength test is a indication of the resistance to cracking, and fatigue test indicate the durability of modified mixes. We can compare from fatigue test a normal bituminous mix and a plastic waste modified mix. Studies have indicated that the fatigue life of a plastic modified mix is always should always be better than normal mix. But if the plastic content in the mix is high, the fatigue life is drastically reduced. Therefore, plastic, optimum plastic, good content of the plastic is 6%, not 8%. And the rating test. Rating test is a indication of the resistance to rutting. Rating test is carried out by a equipment that is known as wheel tracking apparatus. So in this slide, I am showing you the indirect tensile strength test. On the left hand side, you can see the indirect tensile strength test in progress. A Marshall machine can be used for determination of indirect tensile strength, and for this purpose, you can see the loading of the Marshall machine is done by a strip, a steel strip of width 12.5 mm at the bottom of the sample as well as at the top of the sample, and then the load is applied by a Marshall machine. If we see the difference between the indirect tensile strength of unmodified mix and modified mix, you can see on the right hand side in the graph that the indirect tensile strength of unmodified BC mix is 6.8 kg per square centimeter. At the same time, at 6% plastic waste content, it is coming 9.0 kg per square centimeter. So the mix is highly resistant, better resistant to the cracking. So that is the advantage. Similarly, this is the fatigue behavior of the mix. Fatigue test can be carried out on beam, and beam fatigue equipment is shown on the left hand side, and you can see the results. The number of repetitions required for failure are 8,650 for bituminous mix without plastic, and it is 17,554 for bituminous mix with 6% plastic waste in bitumen. So therefore, I recommend we get best results at 6% plastic waste. So, but anyway, it has to be decided what should be the percentage of plastic waste in a bituminous mix. That shall be decided by the test mix design. And the main indicator to decide the content of the plastic waste in mixed design is indirect tensile strength as well as indirect tensile strength ratio. Rutting studies on a bituminous mix can be carried out by Hamburg wheel tracking test, where a loaded wheel is moved over a slab over a beam specimen, and you can see the condition of the beam specimen for rutting test. After test for left hand side specimen is for unmodified mix not having plastic waste, and on the right hand side mix having the plastic waste. So you can say that the rut depth is very high in mix without plastic waste and less in case of the mix with plastic waste. Now the test on recovered binder. So various tests through various tests we can find the difference between the recover properties of recovered binder. So these are the results of RUT test. That dotted line is conventional mix where there is no plastic waste, and solid line is plastic waste. So after 20,000 number of the passes, we can say the rough depth in plastic waste modified mix is only 6 millimeter, which is 8 millimeter in case of the unmodified mix. So that you can say that we can reduce 25% less, we can observe 25% less rut depth in case of the plastic waste modified mix as compared to the normal bitumen mix. So this is all about how we can do the performance studies and the results of a typical case of the performance study on unmodified plastic waste as well as the modified plastic waste. Now I will show you some typical cases where plastic waste modified roads were constructed and monitored for their performance. This is the list of roads in Delhi with plastic waste. All these roads were constructed in year 2012. Mananmai Marg in South Delhi, Sarita Vihar to Kalindi Road A2 in East Delhi, Road 7 is here in East Delhi, road number 71 in East Delhi, road number 62 in East Delhi, and road number 56 in East Delhi. These roads were constructed around, I hope so, 2011 or early, and were monitored for some of these roads like road number 72, 71, 62, 56 were monitored for their performance for 5 years, and these were found performance of these roads were found very good as compared to the conventional bituminous surfacing. We can use a modified drum mix plant for adding the plastic. So we can modify the drum. We can blast. Hello. सुन पा रहे हैं? हेलो.
यस सर, सुन रहे हैं, आपकी आवाज आ रही है सर.
हाँ ठीक है, ओके. So you can see the drum where a central entry can be created for adding the plastic waste, and the location of the central entry shall be beyond the flame, where the flame is there. So, at no cost, plastic waste shall be exposed to the flame. So, we have drum mix plants with double barrel. If we have this is much better for making the plastic waste modified mix. The aggregate may be heated in the first barrel and the plastic waste can be added to the second barrel. So chances of exposing the plastic waste to the flame are totally eliminated. This is the condition of the road before laying the plastic waste modified surfacing. This is a road in East Delhi which is extensively having the extensive fatigue cracking, and this was laid, and this is the view of the plastic road after same road after resurfacing with plastic waste modified mix. So you can see another road in East Delhi after resurfacing with plastic waste modified mix, and see the condition of the road after 5 years. Road performed very well without any distress for 5 years. This is another condition of the road number 72 in 2012 after 3 years. Then you can see this is the condition of another plastic waste modified road constructed after 3 years. So these are the conditions of some other roads constructed with plastic waste during the same period in Delhi. So all these roads were constructed using a batch mix plant because it is very easy to incorporate plastic waste directly to the pug mill in batch mix plant. So with this, I have discussed each and everything related to plastic waste. Now you can have questions. If there is any question, you can ask. Any doubt, anything else. आप सुन पा रहे हैं? हेलो हेलो बड़ा शोर आ रहा है। हेलो आपके कोई क्वेश्चन हैं?
उससे दारी था जी दो अंदर कुछ था
किसने?
कोई पता नहीं चलता कश्मीर के साल हाल क्या तो किस लोग हैं कुछ डर गए
इसने एक ही डाल की थी।
मैं जो बोल रहा हूँ क्वेश्चन के लिए वो जारी है आवाज।
वो पंडित जी टल गया। और पंडित जी को कुछ खिलाओ पिलाओ देसी घी भी इसका दिमाग तेज हो जाए।
इनको बोलो ना चुप करेंगे। अच्छा तो बंद कर दो।
असल में पंडित कोई आंदा नहीं गांजे जी ने लाइन दा कोई नहीं आंदा आराम तनखा कहने
हाँ हेलो कोई क्वेरीज कोई क्वेश्चन?
ओके कर सकते हूं पता नहीं हो के बरसी रवि बेचारा रवि दा वो परेशानी पे
Why black plastics compete?
केस हवा जल्दी जल्दी
Yes, black plastic is not recommended because it contains PVC. And when we heat PVC above 150 degrees centigrade, it can emit carcinogenic gases. So therefore, black plastic shall not be used.
Thank you, sir.
Any other question? Hello?
हेलो
सर नमस्कार सर।
Any other question?
सर नमस्कार।
Namaskar.
मैं AB साहू EPWD सर पन्ना MP। My
जी,
question is that if we provide plastic waste in bitumen work, then what is the मतलब difference economically difference without using or we using?
देखिए, जब आप बिटुमिनस मिक्स में प्लास्टिक वेस्ट डालते हैं
सर
तो उसकी प्रॉपर्टीज जैसे मैंने आपको अपनी स्लाइड में दिखाया,
सर
रेजिस्टेंस टू रटिंग,
सर
रेजिस्टेंस टू फटीग, रेजिस्टेंस टू मॉइस्चर डैमेज, सभी
सर
इंप्रूव हो जाते हैं।
सर
और जब प्रॉपर्टीज इंप्रूव हो जाते हैं
जी
तो मेरा ऐसा मानना है कि जो आपका प्रोग्रेशन ऑफ डिस्ट्रेस होता है सड़क के ऊपर, वो
सर
रिड्यूस हो जाता है।
no,
डिस्ट्रेस डेवलपमेंट कर जी,
my question is economically saving point sir. What
मैं
is
उसी की
difference?
बात मैं
सर
उसी की बात पे आ रहा हूँ, आपकी इकोनॉमिकल
जी
सेविंग पर आ रहा हूँ ना।
सर
उसके दो एस्पेक्ट हैं इकोनॉमी के,
जी
मैं उसी पे आ रहा हूँ।
सर
द aspect number one, direct economy. Okay,
जी सर
direct economy is nil. There is no economy.
okay
There
this
is
is
no economy.
no
And
economy.
indirect economy, क्योंकि आपका मेंटेनेंस एक्सपेंडिचर कम हो जाता है
Of course हाँ
और उसका ड्यूरेबिलिटी बढ़ जाता है। अगर
जी
आपको रिन्यूअल 5 साल में देना है तो हो सकता है वो 6 साल में देना पड़े, 7 साल में देना पड़े,
जी
तो आपको मेंटेनेंस कॉस्ट का सेविंग हो जाता है।
जी
तो
that
दैट वे
means the
देयर इज ए इकोनॉमी।
maintenance amount will save, this will be economy.
Yes, yes,
So thank you sir.
but there is no direct economy.
No, yes okay I understand sir. Maintenance
Okay,
will be no zero, that will be the saving.
no,
In
may
the
not
term of
be
that
zero,
will be economy.
it will be less.
जी sir sir of course thank you sir.
Any other question? Any difficulty in using the plastic waste you can discuss?
Can you say that using waste plastic in heavy monsoon areas will benefit us more?
Yes,
Yes.
it will.
Okay, sir. Thank you, sir.
So if there is no question, I am closing film and this lecture we are sharing with you. They will provide you the copy. So because during film you could not hear sound, so you can run on your own again and see film. It is available at YouTube also. At NRDA site, film is available. Okay, thank you very much.
Thank you sir.
Thank you, sir.